Hello everyone, in this video I am going to be covering the topic cache mapping in computer organization. So first we will understand what is cache mapping. Cache mapping is a technique using which the data present in the main memory is brought to the cache memory and then the data is used by the processor. But the method or process of bringing this data from main memory to cache memory is called cache mapping. The cache mapping can be done using different techniques, and these techniques are direct mapping, associative mapping and set associative mapping. We will discuss about these three mappings in details, but now we will understand about direct mapping technique. Direct mapping is the simplest mapping technique. In this direct mapping maps each block of main memory into only one possible cache line. Let's suppose this is a main memory which contains 128 words, and at correspond we have a cache of 16 words. This cache can be divided in 4 lines. These are called cache lines. So each line will contain 4 words, and here the main memory is divided into 32 blocks and each block will contain 4 words. So let's suppose this is we have first word from first block and we have to map it in cache line. So we will use mapping function for mapping this. The mapping function for direct mapping is k mod n, where k is the block number, mod is the modulo operator and n is the number of cache lines. Here we have 4 cache lines, so n is equals to 4. Let's suppose we have to map a word from the first block, so the block number will become 0 and modulo 4, which will give 0. So this will be mapped to the first line, which is L0 of the cache. In direct mapping technique, a whole block from the main memory is mapped into the cache memory in each line. So let's say we have 128 words in our main memory, which is equals to 2 to the power 7. So the physical address of main memory will be represented in 7 bits. These 7 bits are divided into 2 fields. The first field is block number and the second field is block offset. Offset represents the size of the block, which means how many words a block can contain. In this example, each block contains 4 offset and 4 is represented by 2 to the power 2. So here the block offset is 2. Whereas block number is the number of blocks. So let's say for example, we have a physical address of 0001010. So in this address, the last 2 digits will represent the block offset and the first 5 digits will represent the block number. So here last 2 digits represent 10, which means 2, and the first 5 digit also represents 2. So block number 2, which is B2, and second block offset. So here index second. So this represents W10. Whatever data is present at W10 is represented by this physical address. Now when this block is mapped to the cache, the fields are divided into 3. The block number divides in 2 fields and the block offset remains the same. The block number divides into tag and line number. Since the number of line in cache and the type represents which block from the line is our address. So here we have 4 lines in our cache, which is equals to 2 to the power 2. So line number is equals to 2. Now the total physical address is of 7 bits, and we have 2 bits in offset and 2 in line number. So 7 minus 4 is 3. So we have 3 as our tag. So this physical address is now divided into 3 fields. The last 2 digits represent the block offset, the middle 2 digits represent the line number, and the first 3 digits represent the tag. Here the tag is 0, the line number is second, and the offset is second. So in the second line, of at 0 index, we have B2. So that's how we get the physical address in the cache memory when it is mapped from the main memory. About the associative mapping, or we can also say fully associative mapping. In this technique of mapping, any block can go into any line of the cache. From the main memory, any block can go into any line of the cache. There is no room for the mapping. So let's say we have the similar example. We have 128 words in the main memory and 16 words in the cache. So the 7-bit address will be represented 2 fields: block number and block offset. When in direct mapping, we used to have tag, line number and offset. But here in associative mapping, the block can go into any line of the cache. So line number is not needed, is not present in the address of cache when it is associatively mapped. So the whole tag is represented by the block number bits. So the address of this type of mapping can only be divided into 2 fields. The first field will represent the tag, and the second field will represent the block offset. So this is associative mapping. We will discuss about the SAT associative mapping. SAT associative mapping is a mixture of direct mapping and associative mapping. In this type of mapping, the cache lines are divided in sets. So for mapping each block in the cache, we use the mapping function from the direct mapping technique, which is K mod n, where K is the block number and here n becomes the number of sets. Now how do we find the number of sets? We have a simple formula for number of sets, which is we have 16 words in total and each line contains 4 words. So 16 words are divided into 4 cache lines. So we have 4, which is equals to 2 to the power 2. Hence we will have 2 sets in this example. So this one is set 0 and the second one is set S1. Let's suppose we have to map B0 in this cache. So 0 mod, number of sets are 2, so 2 is equals to 0, which means we have to map B0 in S0. This is the concept of direct mapping. Now in which line from S0 do we have to map the data, which it will follow the principle of associative mapping, in which we can map the data in any line from the cache. So B0 can either be mapped here or here. So this is how SAT associative mapping is a mixture of direct mapping and associative mapping. Now if we say about the physical address here we have the same example. We have 128 words in the main memory. So the physical address will be of 7 bits and it remains constant in the main memory. The first field represents the block number and second field represents the block offset. But when it is mapped to the cache, the field changes, but the last field remains the same, which is block offset, and the block number will be divided in 2 fields, subfields. The second field will represent the set number or number of sets. Here we have two numbers, two sets, so 2 can be represented in 2 to the power 1. So here the set number will become 1. And block offset, we already know we have 2 block offset here because the total bits are 7, and the first field in this represents tag. So 7 minus 3 gives 4. Tag represents which block from the line. So this is set associative map. Thank you for watching this video.